All right, AP Chem, let's look at how we do 5.115. We're going to mix two solutions. You can pause and read this for yourself. I'm just going to go and work through them. So before mixing, how many grams of copper are present in the solution of CuSO4? All right, well, let's come on over here and take a look at how that's going to be done. I'm doing something in this video I haven't done in the others, which is I'm going to actually work problems out in the course of the video. I got one take, because once I write this in, it's in. So there's your molarity triangle and your molar mass triangle. So if I look at my copper sulfate, I'm told that it's 1 molar, and they have 0.05 liters. So if I multiply those together, that just leaves me with 0.05 moles of copper. Cool. And then I'm going to just bring that number over here, 0.05 moles of copper. And so if I do 0.05 times 63.5, I am left with 3.175 grams. And I think we're allowed 2 sig figs here. So I'll just put that as 3.2 grams copper. Cool. Okay, so that is part A. All right, come on over here. Part B, predict the identity of the precipitate in the reaction. Okay, well, we have potassium hydroxide and cupric sulfate. Potassium doesn't precipitate with anything, so we must have cupric hydroxide must be the precipitate. So that's pretty straightforward. All right, part C, write the complete and net ionic equations that occur when the two solutions are mixed. All right, well, that's pretty straightforward. So there is the complete equation. 2 potassium hydroxides with 1 copper sulfate make a potassium sulfate and a copper hydroxide, with 3 of them being aqueous and the last one being solid. But the net ionic equation is just simply the copper reacting with the hydroxide to make cuprate hydroxide. All right. From the calorimetric data, calculate delta H for the reaction that occurs on mixing. Assume the calorimeter absorbs negligible, blah, blah, blah. Some bad assumptions there, by the way, especially that the density of the solution would be the same as that of pure water. 2 molar potassium hydroxide, 1 molar cupric sulfate. These are some pretty high molarities. These things are going to be more dense than pure water, that's for sure. But that's okay. I'm not going to whine about something that makes the math easier for me. So this is just a straightforward Q equals MC delta T. So since we got to assume that the density is the same, the mass is 100 grams. The heat capacity of water is 4.18 joules per gram per degree Celsius. And the change in temperature is 27.7 degrees Celsius minus 21.5 degrees Celsius. That subtraction is going to narrow us down to 2 sig figs, but I'm going to be a little naughty and take a third. And we just got to multiply those numbers, and boom, 2,590 joules. And our work here is done.